of China. Please, Dr. Jin. Microphone, please.
Okay, ladies and gentlemen, good afternoon. My name is Jian Kan Jin from China. First, I would like to explain my thanks to the Internet Seabed Authority for giving me this opportunity to visit Brazil. And my thanks also to Brazil colleague for your hospitality and excellent organization. And the authority gave me the topic for the Chinese effort to develop marine mineral resources. But actually, I could not, this topic beyond my capability. And because actually I'm not dealing with these activities in the national jurisdiction area. For instance, some Chinese national company deal with gas and oil and exploitation in the near or offshore. And also the China Geological Survey now conduct a national program for the methyl hydrates also in the Chinese jurisdiction area. So my job is to deal with these activities for mineral resources in the Internet Seabed area. So my topic is that I gave you a very general introduction about the Chinese effort to develop mineral resources of the area. Next, please. So my presentation will give you some background of the Chinese activity in this area and what we have done and what progress we get. And then very briefly for our future workers. Next. And before my first topic, and I just wonder that what we recognize, what contribution could the deep sea or the area do for the human. I believe that this very large area can offer the new source of resources, including the mineral resources and maybe in the future biological resources, and also give us a knowledge about the ocean. I remember that such once said in the United Nations Assembly that every time people learn, people have a new discovery of the deep sea, and we recognize how limited we learn about the ocean. So without the knowledge of the deep ocean, we couldn't say we learn the whole ocean. Then the third one is I think that the activities of the deep sea can lead in the development of high-tech and equipment of the ocean. And also, I think this year is that people more and more realize that this vast space can also give some part solution for the climate and the environment issues. Of course, then last but not least, we believe that the human civilization and the area can also stimulate the human civilization to establish the order and the regime and the rule regulation and the procedures. Next. So talk about the background of Chinese activity in the area. Now, we first, I would like to give some our interest, why we did this. Next, we do the activities in the area. First, we consider that the national economic requirement. You know that China is a large country and we have a rich resources, but consider the large population. The average is very low, much lower than this the world average. As a development Chinese economy, we need more and more that the mineral resources. So I think that our policy, and this is very important for our policy for the activity in the deep sea. Then the second, I think, is a political or diplomatic consideration. The Chinese government always maintains, pay much attention, the importance to the principle of common heritage of mankind. And this principle, and I think it's very important for our government or the people to participate the development of this regime. And the third one, we think that the activity in the deep sea can create a new area for the technology, and in the future, a new industry development. So this is our interest in them. The next. Then we started this activity in the deep sea. We have some assumption or some consideration. We believe that at the very beginning, we believe the activities in the area should or must be carried out under international regime based on the principle of the common heritage of mankind. Then at the beginning, we started the activity in the deep sea very early, as early as the 1970s, late 1970s. And we did a lot of work in 1980s. And at that time, the Chinese economy was not as good as now. But we believe that investment requirement during this research and development stage can be accommodated to the progress of national economic development. And the regime, also the Chinese regime reform. Then the third assumption is that we believe that technology can be obtained as time is going and by different means. So this is some assumption. Next. But then I give some main event for the development of the activity in the deep sea. In 1980s, a survey entered the sea for the preparation of an application area for polymetallic nodules. In 1990s, China Ocean Mineral Research and Development Association was established. So that's COMRA, and applied for a pioneer area for nodules, which was approved by the United Nations PREPCON in March 1991. Then in 1996, China was elected as a council member of the International Seabed Authority in Group B as one of the largest pioneer investors. Then 2001, COMRA signed the contract for exploration of the polymetallic nodules with the International Seabed Authority. And again, in 2004, China was re-elected as a council member of the International Seabed Authority. But at that time, we take the seat in Group A as the largest consumer of the relevant metals contained in the mineral resources in the deep sea. Next. The mission and the function of COMRA are, and the mission is COMRA, open a new source for all the strategic mineral resources to meet the part demand of the national economic development. And the second is to promote the development of new high-tech knowledge industry in the future. And the third made its contribution to mankind by its activity in the international seabed. And the main function of COMRA as a coordinated body to coordinate the different departments, institutes, and entities in the nation to carry out the activity in the area under the regime of the law of the sea. Next. So I translation to, we have a working guideline, but maybe not so correct. Well, we said that will be insistent and continuous for exploration or survey on the deep sea bed, and then to push forward the development of technology necessary for the deep sea activities. The third one is establish deep sea venture in appropriate time. Next. Now, I gave some introduction about what we have done or the progress we made. Next. The main progress we made in this aspect is the exploration and the technology and the equipment development, environmental assessment, and also capacity building. But also we have other progress, for instance, like something strategic studies or the obligation and implementing obligation as a pioneer investor and now as a contractor. We did something for implementing obligation. Next. For the exploration, since Commerce established, 20 survey cruises conducted since 1991 under the Commerce plan. And we covered the mineral resources. At the beginning, we started polymetallic nodules, and in the middle of 1990, we started to focus on other mineral resources, copper-rich crust and polymetallic sulfide, and data and sample collection for resources and the environmental assessment. Also, with capability building for its future exploration activities. Next. For the polymetallic nodules, in 1991, the Commerce registered as a pioneer to obtain a pioneer area of 150,000 square kilometers for the polymetallic nodules. In 1997, the Authority Council approved the plan of work for exploration. In 1999, we completed the relinquishment of the claim area that we remained 75,000 square kilometers as an exploration area. So in 2001, we signed the exploration contract with the authority. Next. So according to the contractor, the exploration plan mainly cover including to collect the data and sample for evaluation of the resources and the environment, and evaluation of the resources, quality, quantities, distribution, and economic value. Also, environmental baseline survey and environmental impact assessment. I designed the test mining systems, upgraded metallurgically experiments. Also establish a database for our same criteria through internet cooperation. Next. So work on the contractor area. Since then, we identify 3 types of the topography that in our contractor area, and all the epicenter hills, sea mountain chains, and episode basins are recognized in the contractor area. And also we found 5 types of surface sediment occur in the contractor areas, and also different type of the sediment located in the different region in this contractor area. Next. This is topography of the east part of our pioneer area. Next. That's the west part. We actually, our areas divided is separated in the west part and the east part. Next. We also done a geological models cooperated with the authority on the EEZ. That the Commerce contractor area complete the seafloor topography map and sediment distribution map, and using 3-dimensional modeling technique to display the key models results and complete the local scale high resolution maps. And also development the special decision support system modeling and the prediction of the potential nodule resources in the EEZ. The distribution principle of the mineralization's favorability of potential undiscovered nodules deposited in the EEZ as a whole is predicted. Next. And our scientists also made a growth model of the nodules, and this will our scientists expected to further cooperation with the authority. Next. And our attention also to the other resources. From, as I said, from early 1990s, COMRA started the exploration, assessment, and study for other resources, mainly for cobalt-rich crust and polymetallic sulfide. And this is a survey area for the core. Oh, next. This is a survey area for cobalt-rich crust, most in the Middle Pacific Ocean. Next. And this is the main two different type of the sea mountains. One is very flat, other is more roughly. And the next. This is a sample we take, different type of cobalt-rich crust sample. Next. Next. And that 2 years ago, we organized a world-round cruises, and mainly emphasize, mainly attention to focus on the survey for the polymetallic sulfide. And so far, we found some two areas in the eastern Pacific Rising and also southwest Indian Ocean in the Mediterranean region. There's some sulfide deposit. Right now, our vessel is still in the working in the Indian Ocean. This is some sample we took. Next. Next. This is the photos by the TV sample. Next. And so the progress made for the second aspect is the technology and the equipment development. And from very beginning, I think the equipment we used most import from other countries. Then as the time is going, we begin to study and research this kind of equipment ourselves. And this is including the survey equipment and the mining technology and the process technique. Some survey equipment, next. This I show that some survey equipment, I think most we did ourselves, our scientists and engineers, they made some, and okay. Yeah, I just want to make a little explanation. It's because I saw that is a Chinese. And that one is 6,000 meters autonomous underwater vehicle. And this one is TV and camera for deep sea. This is the shallow stage of drilling, especially for the crust. This one, okay. It's especially for the crust. And this is for measure the characteristic of the deep for the seabed. And this is multi-core and sampling. This is a TV crab or TV sample. And this is 6,000 meters and deep tour. And this is a sediment tramp. Next. So for the mining technology that we compare with the other methods, the hydro pump lifting system appears with some, we believe, some potential advantage. And also conceptual design of the subsystems, the details design of the component, and the verification of testing for the design. And also we did some virtual reality research for the mining system. And also we are working out a working plan and the relevant management strategy for the 1,000 meters sea trial. We finished our test in the lake and also designed all the surface supporting system, subsystems, and the determination of the technical specification of some key part of the system. Next. This is what we have done for I forget this work in the sea in the bottom, and this is lifting systems. Next, for the processing techniques, and we have the pre-pilot test of the metallurgical process for the nodules, and the comparison test on the metallurgical process of the polymetal nodules, and the study of the new technology for nodules and direct utilization of nodule, and study of the nodules characteristic in the absorption and degradation of the organic in the western water. Also, processing technique for cobalt-rich cluster and polymetal sulfide is under development. Next. And then I think one of the main work is environmental assessment. And we have carried out a program called the Natural Viability of the Baseline, focus on the collection and analysis of the biological, oceanographic, and geological baseline data. Almost every survey clues data collection, we collect the data and analysis of the baseline. This including biological and chemical and physical parameters. Next. So environment program consider both in the also in design of the mining system and in the research of the metallurgical circuits. The marine environment impact possible caused by the deep sea, by the mining activities, and the form and amount of waste from mineral process and the metallurgy. Disposal process of the residues from the mineral processing and metallurgy. Next. And another progress made for capacity building. This is our main vessels we call the Danyehao, and imported. We bought it from Russia in 1994, and then we make several times renovation. And right now, I think it's the best research vessel in China. Next. This is some equipment in these vessels. Oh, okay, I see that in English. Next. And also we now we carry out a program called the Human Occupied Vehicles, and of course there's a main task, and the progress we made now is we have finished the design, the manufacture, and the assembly, and we finished the open water tank test, and we are now ready for the sea trial, and this is what we call the HOV. Oh, next. This is called HOV. And the main specification is that the max operating depth is 7,000 meters. And okay, I'm not reading that. you can. Oh, next. Oh yeah, this is the main specification. Okay, next. So this is how assembly of this HOV. Next, this is the test process of the test. Next, the capacity building. We also made a deep sea bed sample repository and built in the Qingdao. I think this is also the first one in China for the ocean, especially for deeper ocean.